In section 6.4, we're going to continue with parallelograms, and we're going to use properties of special parallelograms. Remember, we have 6 properties of parallelograms that we talked about. Both sets of opposite sides are parallel. Both sets of opposite sides are congruent. Both sets of opposite angles are congruent. The consecutive angles are supplementary, so 2 in a row add up to 180. The diagonals bisect each other. They cut each other in half, and a diagonal is going to form 2 congruent angles. So we have pictures that look like this for our parallelogram, and I'm going to use those properties to fill in all of the missing angles in the picture. We'll start with the fact that opposite angles are congruent. So since our angle in the top corner is 115, I know the bottom right corner, the entire angle is also 115 because opposite angles are congruent. Consecutive angles, any 2 in a row, are supplementary. So if this top left is 115, then to find this bottom angle, we're going to do 180 minus 115, and we'll get 65. Because opposite angles are congruent, the one across from this will also be 65. Then looking into these angles, at this 65 in the bottom left, we have that part of it is 25. To find the other part, we can subtract. 65 minus 25 is 40. Down at the bottom right, the 115 will do the same thing. 80 and the missing angle have to add up to 115, so this is going to be 35. Then we have some things that we know about parallel lines that we're going to bring into this. So I'm going to sketch a picture up at the top. When I have parallel lines and there's a transversal, which is our diagonal that cuts through, I know that alternate interior angles are congruent. 80 would be an alternate interior to the top part of the 115. 35 would be an alternate interior to the bottom part, and I can use these parallel lines because I know it's a parallelogram. Same thing with the 40 and the 25. They're going to be alternate interiors, so they'll go on the opposite side of that diagonal. However, we're not finished. We also have the angles in the middle of the picture. We can use these triangles and the fact that we know a triangle adds up to 180 to fill in the missing angle. So we have 2 angles in this triangle. We have 80 plus 25, which is 105. To find the missing angle, we'll do 180 minus 105, and this is 75. Because we have vertical angles still, opposite the 75 is another 75. We could either do a 180 with this triangle on the left, 40 and 35 is 75, 180 minus 75 is 105, or we could use our linear pairs, that a straight line adds up to 180, and find that not only this angle kind of in the middle on the left is 105, but the vertical angle across from that is also 105. You could check any triangle you have should add up to 180 degrees. We want to make sure we can fill in any parallelogram. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect, and the diagonals form 2 congruent angles. So I have this bottom, 2 congruent triangles. I have a triangle kind of on the left that's a 35, 65, 80. Same triangle on the right, 35, 65, 80. We also have congruent triangles at the top and bottom, the left and right, but they're flipped. Now we're going to talk about some specific types of parallelograms. The first one is a rectangle. So our properties of a rectangle, it is a parallelogram, so it has all of the properties that a parallelogram has. Opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, they add up to 180, diagonals bisect, and diagonals form 2 congruent triangles. In addition to those, our rectangle is a parallelogram that has 4 right angles. The diagonals are congruent, and the diagonals form isosceles triangles. Not all parallelograms have isosceles triangles. The rectangle does. So in addition to the parallelogram properties, I need to know there are 4 right angles, which we should already know about a rectangle. I need to know the diagonals are congruent. They're the same length. And since they bisect each other, all 4 small pieces of the diagonals will be congruent. For example, if I have a rectangle and I draw in the diagonals, so not only do they bisect each other, but they started out congruent, so each little part will be the same. Because of this, they will form isosceles triangles. Remember, isosceles we use for two sides of the triangle congruent. We have equilateral for all three. So we're going to fill in a rectangle. And this is our rectangle. It's a type of parallelogram. So it has all the properties of a parallelogram plus the ones we just discussed for the rectangle. So to start, I know all four angles are 90 degrees. So this bottom angle is 90. Since this part is 35, 90 minus 35 is 55. I know opposite angles are congruent. This one's also 90, or we can just use the fact that we know a rectangle has four right angles. Then we're going to use that opposite sides are parallel. We could do our alternate interior angles. This 35 goes alternate to the other side. The 55 goes alternate to the other side. Now I'm also going to use the diagonals form isosceles triangles, because if I have two congruent sides, remember I have those base angles congruent. So the 35 will repeat. But all four of these triangles are isosceles. So up at the top, the 35 will repeat. On the left, the 55 repeats. And on the right, at the bottom, the 55 repeats. And if you check, all of those angles add up to 90. Then we also want to do our four angles that are kind of in the middle of the rectangle. So again, I'm going to use the fact that a triangle adds up to 180. 55 and 55 is 110. 180 minus 110 gives me 70. The angle vertical to that is also 70. Now I can double check using this triangle at the top. It has to add up to 180. So 35 and 35 is 70. 180 minus 70 is 110. Vertical to that is 110, and I know I have a linear pair here, and my straight lines should up to 180. They do. 70 plus 110 is 180. So we have filled in all the missing angles. I also know that all four little pieces of the diagonals are congruent, because diagonals in a rectangle are congruent and they still bisect. I know that my opposite sides are congruent. And then if you check, your diagonals form two large congruent triangles. The next kind of special parallelogram is a rhombus. Because a rhombus is a parallelogram, it still has the 6 parallelogram properties. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect, and the diagonals form two congruent triangles. In addition, a rhombus has 4 congruent sides. All 4 sides are congruent. These diagonals are perpendicular to each other. They will intersect, bisecting each other, but also at 90 degrees. And the diagonals bisect the angles. So if I look at the corner at one of my vertices of my rhombus, that angle is being cut in half by the diagonal. Using those properties, let's see if we can fill in the angles in our picture. All I know about this rhombus is that this top left corner is 130 degrees. However, because this is a rhombus, because all 4 sides are congruent, I know that when my diagonal comes up to that 130 degrees, it's bisecting the angle. So the 2 halves are the same. So to find the measure of each small angle, I'm going to take 130 and I'm going to cut it in half, and we get 65 degrees. So both of these are 65. I still have all of my properties of parallelograms. So I know that if this angle is 130, the opposite angle is congruent. It's 130. It is also being bisected. These are both 65. Let's find the bottom left angle. Because I still have properties of parallelograms, 2 consecutive angles, 2 in a row, are supplementary and add up to 180. Therefore, this bottom left angle is 180 minus 130, which is 50. Opposite angles are congruent, so the top right is also 50. Remember, for a rhombus, the diagonals bisect the angle, so each half of this is going to be 25. To fill in the angles in the center, we'll use our 180 again. So we have 65, 25, and we need to get to 180. So 65 and 25 is 90, which means this is 90 degrees. That's also one of our properties. The diagonals are perpendicular to each other. So if you know it's a rhombus, you can fill in 90 degrees all the way around. Now, please note, these are not isosceles triangles. The triangles are isosceles if it's a rectangle. The last parallelogram we're going to discuss is a square. Now, a square is our regular quadrilateral. It is a type of parallelogram. It's also a type of rectangle because all 4 angles are right angles, and it's a type of rhombus because all 4 sides are congruent. So squares have a large number of properties. We have the 6 properties for a parallelogram. We have opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles are supplementary, the diagonals bisect each other, and that our diagonals form congruent triangles. In addition, a square also has all the properties of a rectangle, the 4 that we discussed. So it has 4 right angles, the diagonals are congruent, which makes all 4 little pieces of the diagonal the same. It forms isosceles triangles from the diagonals. Diagonals form isosceles triangle. The square is also a type of rhombus, so it's going to pick up all the properties of a rhombus, the first one just being the properties of a parallelogram. So it also has 4 congruent sides. The diagonals are perpendicular. The diagonals bisect the angles. Now you can see that if you're just memorizing lists, this list for properties of a square gets very large very quickly. So we want to make sure we understand all of the properties of a parallelogram, that those are true for a rectangle and it adds 3 more. Those are true for a rhombus and it adds 3 more, and then all of those properties are going to be true for a square. So I can give you a very basic blank square with the diagonals drawn in and expect you to be able to fill in all of these angles. You will be asked from a blank square to fill in the angles. So to start, I know that this is a parallelogram. I know the opposite sides are congruent. But because a square is also a type of rhombus, all 4 sides are going to be exactly the same. Because it's a parallelogram, I know the diagonals bisect each other. Because it's a type of rectangle, I know that those diagonals are also congruent. So the small pieces of the diagonals will be the same. Because a square is a type of rectangle, all 4 angles are right angles. Because it's a type of rhombus, the diagonals bisecting those angles. So I have 45 and 45 in each corner. Also, because a square is a type of rhombus, the diagonals are perpendicular. They're intersecting each other at right angles. So the center is 90. So we end up with 4 45, 45, 90 right triangles. This will be true for every square. We're going to apply these properties to the homework when you come into class. We'll be working on page 351 to 355, number 12 to 38, 73 to 78. And I'll remind you of this in class, but remember that those large numbers aren't necessarily harder problems, but most of the time those are review problems to go back and make sure you remember what's happening from previous sections.